All right, so here's kind of the deal that we have. Suppose we have a shape that looks like this. And suppose you go to rotate that around the y-axis. Don't draw this. You can draw that piece, but don't draw this. If I rotate around the y-axis, I'd want to do like a dy washer thing, right? Well, watch what happens. Got that picture? If we call this thing f of x right here, and you set up pi times big R squared minus little r squared, that's a problem, isn't it? Can somebody tell me why that's a problem? Everybody see big R and little r are the same? So you'd end up with pi times, f of x squared minus f of x squared dy, wouldn't you? They just go away. They'd be gone, wouldn't they? So the blue function, like that, produces this spot right here, and it also produces this spot right here. Is that better? See now? And so this is really just to provide for you an opportunity that you don't have to do discs, you don't have to do washers. Sometimes we can do things called cylindrical shells. And so everybody has a different way of kind of connecting with this and relating with this piece, but you are going to draw this as I show you cylindrical shells. Okay, you're going to draw this. So we're going to take that and we're going to revolve it over here. Now, try to give you an idea of what the heck you're even looking at. It just takes a little while for people to see, okay? So as this region goes around, okay, we're going to put a shell right through it. So anybody ever seen like a casing from a bullet? Okay, where the powder or whatever is gone, or the bullet's actually gone, but the casing is there. It's hollow through the middle. It's really thin, right? Or how about this? Have you ever seen this? Anybody have like those like Christmas dolls that like stack inside of each other? Do you know what I'm talking about? Say it again. Yeah, anybody Russian nesting dolls, like it's like a little wooden doll, and like you take the top off and there's another one on the inside. Take top off, there's no one on the inside. No one on the inside. Like so that's literally what's happening. It's just shells. There's one that sits inside of one that sits inside of another one. Like they keep on gathering over and over and over again. I'm going to draw one more here. See all those shells? I got 3 of them there, and they all sit inside of each other. They kind of continue to stack and stack and stack. Like a soup can. Like a soup can that sits inside of a soup can, sits inside of a soup can, sits inside of a soup can. And eventually, you're going to get a volume out of that. Here's the really cool thing. You can take this green shape that you see there, and you could unravel it. Like you could take a soup label and unravel it. If you unravel it, what shape are you going to get? A rectangle. And rectangles are awesome. Do you know why rectangles are awesome? Because it's easy to find the area. So look at your green thing here. Is the width dx or dy? Does it have horizontal width or does it have vertical width? Dx. Ooh, if I have a rectangle, I know I need this height and the length, right? Can somebody tell me what determines the height of the rectangle? The function. Well, that was easy. And now we just need 2 pi times our radius. If you unravel a soup can, the length is going to be the circumference, which is 2 pi r, right? So we get 2 pi r. Multiply all that together and you get 2 pi times the radius times f of x times dx. That's the volume of 1, and you want an infinite number from a to b. It looks complicated. It's actually an easier way of doing it than doing washers a lot of times. Let's do a straightforward example. Sorry. I'm getting excited. I don't appreciate when Caleb laughs at me. I'm going to take this function, y equals 2x squared minus x cubed, and y equals 0 revolved around the y-axis. I'm going to take this, I'm going to factor out an x squared to get 2 minus x, so I could show you what the shape looks like. Everybody agree that that crosses the x-axis at 0 and at 2? And that's what it looks like, okay? Now, I get that you may not know that. I'm just showing you that's the picture that you would see on your graph, okay? We have y equals 0. And we have the y-axis, okay? We're going to revolve it around the y-axis. So we're going to take this shape and revolve it here. I can't do this. Why? I can't do a washer. Why? Because the inside and the outside are the same. See that? So I have to use a different option. I don't want to use a washer. I'm going to use instead a cylindrical shell. We're just going to draw a rectangle there. For this purpose, I'm going to put x here. I'm going to say that we drew the rectangle at a position of x. Okay? So just some value on the x-axis. Could be 0.5, could be 1, could be 1.8. I'm going to revolve that around over here. As I revolve that rectangle around, I get this beautiful Russian nesting doll. I want to find the volume of one of those things. If I can find the volume of one of those things, then I can find the volume of the entire region. In order to find the volume, I will unravel it. Is the width dx or dy? Look at your original rectangle. Dx. What determines the height of this rectangle? The function 2x squared minus x cubed. And now the most important part. In order to determine the length, I take 2 pi times the radius. We must determine what the radius is. Does everybody agree that the radius is this distance? So if this is 0 and this is x, what's the distance from x to 0? X. Everybody agreed? If this was 1.8, then the distance would be 1.8. If this was 0.4, the distance would be 0.4. The radius is whatever x is. Agreed? So therefore, instead of r, we just write 2 pi x. So I'm going to multiply all those together. 2 pi times x times 2x squared minus x cubed dx. That's the volume of 1. I want to do an infinite number. What are my bounds? 0 to 2. And that's the setup. Rest is easy. What's so nice about the cylindrical shells is you don't have to square anything. But you notice with the washer, sometimes you square stuff, it's like, oh man, that kind of makes it messy. You don't have to square anything. It's super easy. You just go 2 pi integral 0 to 2. You got 2x cubed minus x to the 4th dx. Antiderivative of 2x cubed. X to the 4th over 2. Stay at a Holiday Inn. It's a joke. Let me get it. Sorry. Minus x to the 5th over 5. Evaluated 2 and 0. If we plug in 2, we get 2 to the 4th is 32 over 2 is 16. 2 to the 5th is 32 over 5. Sorry. 2 to the 4th is 16 divided by 2 is 8. 2 to the 5th is 32 divided by 5. I got 5 here. Or 2 pi times 40 over 5 minus 32 over 5. 16 pi over 5. Not too bad. Let's try one more. This is your last example of third quarter, folks. It's your last example of third quarter. How's that feel? You don't get the Holiday Inn reference? Have you ever seen the commercials? Guys like having brain surgery or something. He's like looking at a doctor. He's like, how many years of experience do you have? He's like, I have no experience, but I did stay at a Holiday Inn last night. It's like the idea is that you get such good sleep that you feel great that you can do anything. No, you don't reference the commercial? Oh my goodness. Okay, thank you. You just big time me. I'm not in the Netflix world, I guess. I need to. All right. Still waiting on your list of music. Which none of you have heard the song Pride in the Name of Love by U2. Which is unbelievable because it's all about Martin Luther King Jr. Somebody has failed you. Okay, thank you. Y equals x minus x squared. Tell me something about it, anything about it. It's a function, good. So, tell me something else. You can take out an x, yeah, so you can get x times 1 minus x. So therefore, it's going to go through the x-axis at 0 and 1, right? What shape does it make? Parabola, yep. So we got 1, got this parabola, boom. Y'all good? Where are we rotating around this time? 2. So if I rotate it around x equals 2, I would get that shape over there. part of me wants to draw a washer. Why can't I draw a washer? They're the same. So instead, I'll draw a cylindrical shell because it's easier anyway, and life is awesome. See, this is the time where like your parents ask you, like, what'd you do today in math? You're like, I rotated solids around different axes and found volumes using cylindrical shell methods. And they think you're probably the smartest person on the planet. Right? They're sending you to Harvard by this point. You're disagreeing. I don't know how to find the volume of all of these, but I can find the volume of one right now. Is the thickness dx or dy? Dx. For your assignment, I gave you all just dx problems instead of dy problems. We don't need to go that far. Yes, I won't. I'm not gonna. What's the height? X minus x squared. And then we have 2 pi times the radius. Now this is a little bit different, folks. Look at where I made my rectangle. I made it right here. It's a value between 0 and 1, right? Suppose it was at, we'll call it 0.8. Suppose I drew this spot at 0.8. What would be the radius? Would you agree the radius is 1.2? You did 2 minus 0.8. So if this is x, then the radius is 2 minus x. You have to do right minus left to find your distance. So there, no. So the expression for my, being I didn't rotate it around the x or the y-axis, the expression is 2 minus x. So you have to take your right minus your left to find your radius. But now it's easy. Now we just multiply. 2 pi times 2 minus x times x minus x squared dx. And we integrate from what to what? Look at our original area, 0 to 1. Two pi times the integral from 0 to 1. I got to multiply this out. Negative x times negative x squared is positive x cubed. 2 times negative x squared is negative 2x squared. This is another negative x squared, so negative 3x squared. And then I've got 2 times x is 2x. Did I do that correctly? Antiderivative x cubed. X to the 4th over 4. Antiderivative of 3x squared is antiderivative of 2x is if we just plug in 1, we get 2 pi times 1/4 minus 1 plus 1. Isn't it great when teachers write problems like that? Two pi times 1/4 is going to be 2 pi over 4 or pi over 2, which is 90 degrees. That's a little math humor right there. I don't know if it's like review from Trig. It's like supposed to be like, haha, Mr. Gens, you're funny. Thank you for the insight. Did you plan that? Oh, no, everybody thinks it's serious. It's not. Okay, good job.